In this video, we're going to show OmniLab users how to create a project. The first step, of course, is to start OmniLab by clicking one of the shortcuts created by the installer. To start a project, or create one, you click on the Project menu bar button up here. And you'll notice that there's no way to do that. That's because when you first start OmniLab, you are in what we call the technician mode, and the technician privileges do not include the ability to create a project. Those are reserved for the super user. We click Authenticate and enter the password given to you by Guided Wave. And now we have super user privileges. Now when we click here, we find that we can create a new project. So you click that and enter a name for your project. You also need to select where you want OmniLab to store the project files. I like to put mine in my home directory. I like to create a directory called OmniLab and then a projects folder inside of that. So I have selected that, and you see that path here. We'll say OK. OmniLab needs to be able to communicate with the analyzer's database. To do that, it needs the IP address of the analyzer. In this video, we are running directly on the computer inside the cabinet of the narrow lab unit, so localhost should work. So now we've created a project. Right now it's an empty project, and we need to define certain things in order to complete it. We're going to start by configuring the channel that this project is going to collect scans on. So you click Configuration, and you select all of the configuration that you want for this project. The collection method is the way you're going to collect scans. We have two different ways of collecting scans at this point. Push button, where every time you push the button you get a scan. We also have an interval method, which takes scans at a regular interval without having to hit the button every time. We're just going to stay with push button. We're going to work on channel 1. Start wavelength and step size are here, and stop wavelength. The number of averages, co-averages that you want for each scan. Filter position typically is open. Occasionally you might want to do long pass scans. We're going to leave the open position here. The defaults that you get are most of the time what you're going to use. Let's continue by testing the ability of OmniLab to talk to the database by clicking this button. And we can see that it did work. And we're going to go ahead and save the project at this point. Oh, one thing I should point out. Let's make a slight change to the configuration. Let's change this value. Notice that when you make a change to any of the configuration of the project indicates that it's not saved. It's in a changed state by putting its name into italics. And you can go to Project and save it here, or as a shortcut, you can hit Control S, which you can't see me doing, but I'm going to click Control S. That saved the project. Now its name is not italic anymore. All right, after you've chosen your configuration, you will want to create at least one prediction method. Prediction methods are Python scripts that will be executed every time a scan is collected. And the purpose of this script is to produce an answer. And this demonstration, this will be a simple Python script. In other videos, we'll show you how to create scripts that invoke third-party prediction engines such as unscrambler and eigenvector. Let's open up the prediction methods window and click Add. We have to assign a name for this method. We're going to collect the absorbance at a particular wavelength. let's say 1600. So I'm going to call the script AU1600. Okay, you see the name over here. You can have multiple prediction methods. We're just going to have one. To get started with this prediction method, if you have a Python file already written, you can select it by clicking Browse, or you can create a new one. So we're going to do that. We're going to create a new one. What this screen is asking is, where do we want to store that file? And it's always a good idea when you're creating your projects to keep all of your project-related files under the project folder. And as you can see here, here is that path that we selected earlier. And this project is being stored in a folder called First Project-OmniProj. So we want our script file to go inside of that folder. And we're going to accept this name as the name for the script. You can give it another name if you wish. And what we've done is we have seeded this script file with a script simply as an example. We have opened this Python script for you in Notepad. If you have another editor that you would like to use and that has been installed on your machine, you can change it here. But we're going to leave this as Notepad for now. So I'm basically going to start over. So I'm going to delete all this. And our script is going to be something very simple. We're going to say answer equals get absorbance at scan 1600. Okay. All right. So every prediction method script that you write has to set a value for a variable called answer. So this is just regular Python code, but we reserve the variable answer as the output mechanism for this script. So you must set a variable called answer to some value. Get absorbance at is a function that resides in our Python library that we have provided for doing various things with scans. This function gets the absorbance from this scan at this wavelength. The variable scan also is a reserved word, and it contains, when you run your script, it will contain the identifier for the scan that this prediction method is being invoked for. For this script, this will return us the value of the scan in absorbance at this wavelength. So I'm going to save this, and then I'm going to close it. And now we're going to test run it. So test running does a couple things. It first will compile your script from Python code into Python bytecode and make sure that you don't have any syntax errors. And it will also invoke this prediction method on the latest scan taken on this channel. Well, we don't have any scans on this channel yet, but we have a spectrum that we've saved for that case. And this is going to run that script that we just wrote. There, we run the scan, and you can see the result here in this little pop-up. So now that we know that the script compiles and runs and produces a number, we're ready now to save this. Notice that, yes, the project is in a changed state. So we can click Update Method to save the changes we made to this window, and then we need to save the project by clicking Save. The next step in setting up your project after creating a prediction method might be to add lab values to your project. Lab values are simply placeholders for holding laboratory produced quantities on the sample that you have scanned. So typically you'll be taking scans of samples, and you'll send those samples off to the lab to have them test for the lab values that you're interested in, and they'll run their tests and give you back a number. And those lab values that we have in our project are a placeholder for where we will enter those values. To add a lab value, you simply click Add and give it a name. We're going to assign this lab value a simple name. Now that we've added the lab value, notice that the project has changed, so we're going to save it. I hit Control S to do that. We're almost to the point of being ready to collect scans, but before you collect scans, it's always a good idea to re-zero the instrument. We'll do that by clicking on Zero Scan. Brings up this window. This window does quite a few things. It takes zeros. You can use it to zero your SMS channel if you have purchased the stability monitoring system. You can also have it run wavelength validation scans to make sure your wavelength coefficients are still good. We're not going to do that today, so I'm going to uncheck that. And to zero the instrument, you want to make sure that your probe is clear of any sample material. So you typically pull it out of the sample, you clean the probe and dry it, and then take a zero scan. The zero scan is finished, and it's hard to see, but the green line on this chart is showing you the current zero that we had, which is also being used as the benchmark for future zero scans. The red scan is the scan we just took, and you can see that they're very close. We've also done an analysis of the scan. We've compared the shape of the scan and the magnitude of the scan, which is the area under the curve, and compared them to the benchmark, and we see that they're all very close. So this was a good zero scan. We're going to accept that scan as the new zero scan, clicking this button, and we're going to say accept. And now we have a good zero. Now we're ready to take scans and collect data. So let's close this window and open the Collect Spectra screen. There's nothing left to do here except perform scan. So at this point, you would take your probe, you would put it into your sample, wait for the liquid to settle down, and then you click Perform Scan. As scans come in, they're added to the table. We also plot them in this chart. This channel actually physically has a jumper on it. I don't have a probe and sample material here. So we're just taking scans of nothing. So you get the typical noise pattern scan that you get when the channel's jumpered up. If you want to take another scan, you just push the button again. So what you would have done at this point is you would have removed the probe, cleaned it off, most likely, and then inserted it into a new sample. There, now we have a second scan. And you can collect as many scans as you want. This table can accept as many scans as you want to take. Also, this table allows you to enter other information to be carried along with the scan, such as the sample name here, any kind of comment that you might want to attribute to this scan. If you want to enter a timestamp here, we typically would use the sample timestamp here to enter the time at which your laboratory produced any lab values. And the lab value that we created earlier here will accept a numeric value of the value that you got back from your lab. And the final column shows the predicted value that the script that we wrote earlier has produced. So all of this information is held in this table. Typically, you would collect all the data you want, as as many scans as you want, and then you typically export the data. You can export individual scans, or using the control button you can select scans and omit others. Today we're just going to export them all by clicking that. You'll be prompted for where to store this file. Notice that it's suggesting that you store it in the project folder, which is always a good idea. Or you could change it to be some other location. We're going to accept this name. You do have a choice of formats. We support the guided wave JSON format. We also support the unscrambler ASCII format, the pirouette ASCII format, and row-oriented and column-oriented CSV files. So we're going to accept the guided wave format and click Save. I've already saved the file with this name, so we're going to go ahead and overwrite it. And there, the data has now been exported. So this video has shown you how to create a simple project, add lab values and prediction methods to the project, how to collect a zero, and how to collect and export data.